Excuse me. Hi everybody. This is our video that we are doing on our properties of mathematics. Okay, so we cut this and glued it into our journal the other day. So here are the categories. There are 4: commutative property, which you may have heard of, associative property, then we've got identity property and inverse property. Okay, notice they all apply to multiplication and addition, not subtraction, not division. Okay, so let's start with commutative first. So on the inside of my foldable, I went ahead and did a dividing line. You can do it across this way too if you want. Okay, so let's start with commutative. Now you guys are familiar with it. Remember, commutative means the order does not matter when you have an addition problem or multiplication. So let's give an example. If I have 7 plus 9, we know what that is. That is 16. Is that the same thing as 9 plus 7? Yes, it is. So we say that the order doesn't matter. So those are commutative, which would be the same thing if you had letters, if you had variables. So I can say A plus B is the same answer as B plus A. The order does not matter. Let's try multiplication. If I have 4 times 6, well, what does that equal? 24. That equals the same thing as 6 times 4, which is 24. Those are equal. That's a true statement. Okay, so if it holds true numerically, it holds true with variables as well. So I have A times B is the same thing as B times C because of the commutative property of mathematics. Okay, so now I want to go ahead, that's all for commutative. I want to go ahead and talk about associative. Okay, so let's define it. Associative says the way numbers are grouped. Now this is only for addition and multiplication. The way numbers are grouped does not change the sum or product. Okay, and you can remember this by when you group numbers, you put parentheses around them. So suppose I have 3 plus 9 plus 4, and I want to group it in this manner. Okay, so the way I remember associative property is I think, ooh, who you associate with, who you hang out with. And I picture these as like, they kind of like they have buddy arms. They're buddying up together. They're associating with each other. So if we solve this using our order of operations, we would say that this is 9 plus 4, doing our parentheses first. That's 13. So we would bring down this other 3 plus 13. Okay, we know that that is 16. Okay, what if I group it a different way? Let's see if it's equal. So I have the same numbers in the same order, but instead of these guys hanging out, I'm going to associate or group these first two terms. Okay, so order of operations says do parentheses first. 3 plus 9 is 12. I'm bringing down the rest of my equation. 12 plus 4 is 16. Are they the same? Yes, they are. Okay, so we have just proven the associative property of addition. Let's try it with multiplication. Oh, I'm sorry. Let's try it with multiplication. Well, let's talk about letters. So if I have A plus B plus C, and I group B plus C, is that going to be the same thing as grouping the others? Yes, it will. And we proved that up there, so it will be the same. Okay, let's talk about multiplication. Suppose I have 2 times 3 times 4, and I group the 2 and the 3. Okay, well, what does that equal? I'm going to solve this algebraically, following my steps. So 2 times 3 is 6. 6 times 4 is 24. Would that be the same thing? I'm going to draw a dividing line here between my addition and my multiplication. Would that be the same thing if I have the same numbers and I group them differently? Will it be the same? So 3 times 4 is 12. What is 2 times 12? Isn't it 24? Yes, these are both equal to 24. So we have proven for addition and multiplication, grouping the numbers differently doesn't matter. So let's do it with letters for multiplication. So if I have A times B times C and I group these two, it's the same thing if I group the others. Sorry. Okay. All right. Now let's talk about identity property. Now you've probably heard a lot about having your identity stolen. Your identity is referring to who you are. So here are the rules, and numbers have an identity, sort of. So here's the first one. The sum means adding of any number. Okay, let's just think for a minute. What would you add to a number so that it never changed? It kept its identity. So if I chose the number 13, what would I add to it to keep it 13? I would add 0. The sum of any number and 0 keeps the identity. It keeps the number the same. It keeps the identity. Okay, that's for addition. So let's prove that. 13 plus 0. The 13 does not change when you add 0 because of the identity property. It keeps its identity of 13. It didn't change. Okay, let's try the multiplication one. So the answer for a multiplication multiplication question is the product. So the product of any number, okay, so now let's think about this. If I'm going back to my number of 13, what would I multiply that by to keep its identity? Any number times what keeps its identity? Well, of course, any number times 1. Oops, sorry. Nope, don't need that. Sorry. Okay. Let's talk about this using variables. So for the addition one, could I say what plus b is going to equal b? Well, of course, b plus 0. And if I'm using b, what times b is going to leave me with b? It's going to keep the identity intact. Well, of course, 1. All right, now let's come over here to inverse. Inverse is really fun. You've already had part of it. When it's talking about addition, you remember the term additive inverse. So here's the rule. The sum, because we're talking addition, of any number and its additive inverse, underline that, additive inverse is 0. Okay, you say, Miss Hawkins, I don't remember that at all, but I bet you do. What if I have 6? What would I have to add to that 6 to get 0? Think of the number line, and I'll give you a clue. It's negative. Right, you're going to have to add the opposite. So the opposite of 6 is negative 6. 6 plus negative 6 is 0. So remember, that's where the term additive inverse sounds familiar because it just means the opposite. Okay? So what would be what would I have to add to negative 8 to get 0? What's the additive inverse of negative 8? Well, what's the opposite? 8. Okay, so that, let's go algebraically here. If I have the letter A, what would I have to add to A to get 0? What's the additive inverse of A? Well, it's negative A. Okay, so that's for addition. Okay, I'm going to put over here opposites because you remember that from when we were studying integers. Okay, now for multiplication, the product of any number, and you've had this term before too, the product of any number and its multiplicative inverse. Multiplicative inverse equals 1. Okay, so let's say, what would I have to multiply 2 by to get the answer of 1? 2 times what is 1? Well, isn't it 2 times 1/2? 1/2 is the multiplicative inverse. Underline that. You've had it before. We also have called it the reciprocal. Okay, so what would I multiply 6 by to get 1? Wouldn't I multiply it by 1/6? And think about it this way. 2 halves is 1 whole cookie. 6, if I broke a cookie into 6 equal parts, I'd have 1/6. If I had 6 of those 1/6, I would have 1 whole cookie. Okay? All right, so let's do it algebraically. Suppose I have A. What would I have to multiply A by to get the answer of 1? Well, I want the multiplicative inverse, 1 over A. Okay, so you might remember multiplicative inverse. I'm going to circle opposites up here. You might remember multiplicative inverse known as reciprocals. Okay, remember? Keep, change, flip. We use the reciprocal when we flip it. Okay? All right, that's all. Bye.